news with today's lesson. It says systems of inequalities. We have already graphed inequalities. We already know how to graph inequalities. So why do we have a new section called systems of inequalities? Well, we're just going to graph more than one on the same Cartesian coordinate plane. That's what we're going to do. So there really isn't new learning today, just a new way of thinking about where our solutions are going to be at. So our objective is to solve systems of linear inequalities. Like I said, at least 3, your pencil and then a couple colored pencils, that type of thing. And these are to solve complicated situations, usually complicated business situations. And that's because businesses have what are called constraints. They can only spend so much money on labor. They can only spend so much money on materials. And this is a really good example for us to see how inequalities would be used. It says, you want a car that is less than $20,000 after 5% sales tax is added. Probably going to have to be used to make that happen. You want fuel costs under $2,000 for the 10,000 city miles that you expect to drive next year. So you're thinking ahead about this thing. You know, you've got this much money for the car, you've got this much money for the tax, you've got this much money for the gas. And it says you estimate that the cost of a gallon will average $4 per gallon. Well, maybe that's because you want to go on the high side just in case, you know. Which car best meets your conditions and explain. There actually is evidence for the $4 per gallon. About 5 years ago now, they did a huge poll where they asked people, at what point would you cut down your gasoline consumption? How expensive would gas have to get for you to say, I got to get a smaller car because I just can't do this anymore? And the cutoff was $4. People said, that's it. I'll have to do something to conserve if it reaches $4 per gallon. So this is pretty good math. And it looks like they've got a lot of different cars picked out. And that's the problem. There's so many choices here. So figuring out what choice down here is going to fit all your conditions up there requires a lot of mathematical background. So down here, we're just going to look at without the words first and see how this all comes together. This says we're going to solve a system by graphing. So like I said, I look at this and I think, well, we've already done that this year. We can graph that. But then there's a second one. And that's because there's a second condition that it has to meet. So what we'll do is we'll graph the top one. We're going to shade a half plane. And then we're going to graph the bottom one and shade a half plane. But the answers are only where the double shading occurs. So answers must be shaded for both. The answers must be shaded for both. So when we see where that region is, where there's double shading, we are going to totally over-exaggerate our shading to show me when I grade your paper that you know exactly where the region is that we should be using. So we'll get started. The top one, pick a color, circle it in that color, and let's write it over here so everything is color-coded. Now what we need to do is we need to think of this as if it were in standard form. So when we're graphing these, this is where we pretend that since this is in standard form, we pretend that it says equals. So what we have to do is say, all right, how do I do standard form? Well, standard form is where I say, what if I don't have any x's? What if the x's are gone? And I pretend that says equals. Negative y equals negative 3. You have to put a 3 in there to make that true. So that's going to be 0, 3. This is the thumb method. 0 in for y, cover it up. 2 times something is negative 3. We'll just divide by the 2. It would be negative 3/2. So our first boundary line is going to go through 0, 3, and negative 3/2 is 0. So let's find where those 2 points are. Like so. And then we pause, because we have to think dashed or solid. What do you think? Yep, got an equals bar. This is solid. I'm just trying to give myself something to aim at because my lines have not been real straight today. There we go. How do we figure out which side to shade on? Test a point. Yeah, I know what you're thinking. That'll work for the other one, but this one we're going to test a point. So let's test. Doesn't go through 0, 0. Let's test 0, 0. 0 minus 0 is 0. Is 0 greater than or equal to negative 3? Greater, isn't it? Okay, so we need to shade where 0, 0 is. Now I can't, you guys can put your pencil down sideways and do a really good job shading. I can't do that up here. So I kind of have to just do some lines. I'm going to switch colors because that's not the only one we have to graph on here. I'm going to go over here and I'm going to use green and color code that second one. Is that in standard form? No. This one's ready to go for graph. How do you graph something that looks like that? Down 1 and right 2. And we could do that a couple of times, which will help me out with getting things lined up nice in a straight line. But then you pause, because it could be that this one was dashed. But is it? No, this is solid. Now, Wyatt was up here and you couldn't see him because he sits in the front row. When I asked about the shading before, he said, look at the thing, the inequality. When it says y is greater than or equal to, when you solve for y, if this says greater than, we're shading up. If it says less than, we're shading down. This is shading up because it's y is greater than or equal to. So we would shade above the line. And I got Christmas going on in one chunk of this graph, red and green at the same time. So because those were my colors, I'm going to go over here and really over-exaggerate that I know that everything right here is an answer to this system. Because not only did it meet the requirements for the first inequality that we graphed, it also met the requirements for the second one that we graphed. It has to. It has to work for both. So any points that we pick out in here will work in both of those inequalities up there. There it is. Like I said, no real new learning, but just trying to pay attention to where is the double shading, or if we're graphing 3 of them, where's the triple shading, all that good stuff. So far, so good? All right, let's try another one. I'm going to color code this one. I'll use blue for the top one. Slope intercept or standard form? So what do we do to find standard form lines? Thumb method. Zero, covered up. 2 times something's 4. What's the something? 0 in the y, cover it up. What does x have to be? It has to be. Let's say 4 equals 4. So 0, 2, and 4, 0. I have to scoop this up a little bit. Master solid. Solid. How do we figure out where to shade the standard form? Test a point. Can we test 0, 0 on this one? Yeah, it's not on the line. Test 0, 0. So 0 plus 0 is less than or equal to 4. True. Shade down towards 0, 0. Not done yet. One more. So I'm going to change colors. More of that one. Y is greater than or equal to negative x minus 1. Point slope or standard? Point slope. How do we graph in point slope form? Go down to negative 1. And 1. Up 1 over 1? Down 1. Up. Yeah, negative 1. Here's our slope. So down 1 and to the right 1. I'm not necessarily a fan of the fact that they're making us do solid lines for everything here to start off with. We do need to stop and pay attention and say, is this dashed or is it solid? You're giving us a lot of equals. And Abby said shade up. Why'd she say shade up? Greater than. And again, while we're shading above that line, you want to look for the double coloring. Where did you have double shading? And this is between these two. It's any point that's on the line, that's why we made it solid, but it's also all of this good stuff in here. And there are an infinite amount of them. We just can't fit them all on the Cartesian coordinate. Because this is going to keep going down there forever. But this is a visual representation of where the answers are. The answers are in here. Okay? So, before we move on to any more problems, 43210, me how you're feeling about just this part so far. So come back. Quite a few we talk standard form versus good. All right, so couple that are saying, hey, let's do some more of these. We're doing more. We are. But we have to take a little break here and set up some more problems. This first one, I think we're just going to set it up. We're not actually going to graph it. And that's because the numbers are so big. I want us to be able to do one where the numbers aren't the problem. You know, everything will work out smoothly. So we'll just set this one up. Fundraising. Your city's cultural center is sponsoring a concert to raise at least $30,000 for the city's youth services. Tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 500 orchestra seats, how many of each type of seat must they sell? Here's what I need from you. I need you to find me a total. We're going to do this the same way that we do equations. Find a total in that information. 30 grand. Now, will they be happy if they make 29,000? What it says. Are they going to be thrilled if they make 29? No, they won't. Because they want at least 30,000. So, could they get exactly 30,000 and be happy? Yes. Could they get 31,000 and be happy? Oh yeah, they'd really be thrilled. But the big deal is that total is about money. So what we have to do is go find out the other information about money. So what do you know up there that has money involved? 20 for the balconies, 30 for the orchestra. So X will be the balcony. And Y will be the orchestra seats. All right. So far, so good. Jake. We need another total. Somewhere up there must be another number that represents a total. 500. Okay. Now, 500 what? Okay, so should they sell 501 orchestra seats? They can't. Somebody be sitting in somebody's lap. So less than or equal to, and the orchestra seats are just Y. Looks like that. Now, the reason I want to do this one to help set it up is because look at that. Graphing stuff with 30,000. I am going to show you how to graph with your graphing calculator today to check your answers. But these numbers, that's just, it's too messy. So what I want to point out about this one is, even though it doesn't say anything else, there are actually two more inequalities that we need to write here. Here's why. Can a place sell a negative amount of balcony seats? Can they sell a negative amount of orchestra seats? So we really need to put X is greater than or equal to 0 and Y is greater than or equal to 0 just to set this up correctly. And that's because if somebody didn't know what the problem was about and they just looked at our math, they would think they can have negatives. And we know that you can't sell negative amounts of tickets. Well, I suppose if you're a scammer, you could think that way, but no, you can't sell negative amounts of tickets. So this one would be very messy because of the size of all the numbers. So we're going to do one about pizza that doesn't have such horrible numbers. So let's go to the next one. A pizza parlor charges $1 for each vegetable topping and $2 for each meat topping. You want at least 5 toppings on your pizza. You have $10 to spend on toppings. How many of each type of topping can you get on your pizza? Find the total. $10. Now, is that your limit, or can you spend $11? So it has to be less than or equal to. And that was about money. So what other information do we have up there about money? $1 for x, which is veggie toppings, plus 2y, and that'll be our meat toppings. So x veggie, y meat. We're going to need at least one more total here, or we don't have a system. Let me see. At least 5 toppings. So if you get 4, will you be happy? If you get 5, will you be happy? Yeah, 5 is at least 5. How about 6? Oh yeah, even happier. So it's going to be greater than or equal to 5. Does it say we need twice as many veggie toppings as meat toppings or anything like that anywhere? We just know we need to get both. That's what we know. And we also know you can't put a negative. Some people would like to put a negative amount of veggie toppings on their pizza, but you can't put a negative amount of toppings on your pizza. So we would say x is greater than or equal to 0 and y is greater than or equal to 0. Now what that means for us when we graph is, we're just going to graph in the first quadrant. We don't need any of the negatives at all. We'll just graph in the first quadrant. And I like these two equations because they're going to go really fast. X plus 2y less than or equal to 10. So let me get the 1 out of there. And that's in standard form, so we can do the thumb method. 0 for the x. What do we need for y? Make that true. 5. Which makes sense because the meat toppings are $2 a piece. That's $10. And then if we don't get any meat toppings, we go vegetarian. How many do we have? 10. Yeah. So 0, 5, and 10, 0. Dashed or solid? Solid. And now here's the one good thing about word problems. We know we have to shade down. This was about money. You don't have a limited amount of money. You can't just suddenly say, I'm going to have 20 of each out here. That doesn't make any sense. So far we got this little triangle. Unless you know something. I'll be back. $2. And they'll never come back. Yep. All right, let's try x plus y greater than or equal to 5. Got your 0 in for x. What would y be? 5. Got your 0 in for y. What would x be? Yeah, 5, 0, and 0, 5. So that's going to go right on the top of this one. But 1, 2, 3, 4, 5, right there. Dash your solid. Solid. I know you guys already have this. But you wanted at least 5 toppings, right? So do you want to shade down towards 0, 0? No. So this one has to shade up. And again, it's just kind of thinking through the word problem stuff. And we realize, well, that's going to give us this little triangle thingy right here. So we can order anything in that little shaded region. We could get 1, 2, 3, 4, 5 of the veggies and 1 of the meats. We could get 1, 2, 3, 4 of the veggies and 2, 3 of the meats, because it would be on the line there. So you know all of your choices that you can get. Let's just write down one of those choices. 5, 1, so 5 veggies, 1 meat. But know that there's more. I'm going to put dot, dot, dot. We're just not going to write them all down. We're not going to write down all the choices that we have. That's what the visual is for, to help you get that piece. Now, we can do this problem totally on the graphing calculator. But you have to have a calculator first, and then you have to have a certain app on your calculator. So if you don't have a calculator, come up and see me. Let's do this first. Some of you, when we go to the app, you're going to find out you don't have it. That's okay. Just watch along with the rest of us. Oh, there you are. All right. First off, we can't put anything into our calculator that's not solved for y. So we are going to have to solve these for y. So the top one was x plus 2y is less than or equal to 10. How do we get y alone? Subtract x. Divide by 2. All right. So we have y is less than or equal to negative 1/2 x plus 5. And that's the top equation. The bottom one is much easier because it was x plus y is greater than or equal to 5. So how do we get y by itself? Yes, a lot of people were whispering it. So this is what we're going to put in our graphing calculator. I'm going to circle that in red. That one and that one. Okay, Cedar Home, but it doesn't have less than or equal to, greater than equal to. It has equals. Well, that's why we're going to turn the app on. There's an app that makes it less than or equal to, greater than or equal to. And that is under apps, right here. Now, I have lots of them. Some of you only have finance. And if you have a newer color calculator, that's because it doesn't come standard with those calculators. You have to download it. But it's very easy. All you do is Google Texas Instruments, choose your calculator, download apps. N equals is what we're looking for. So scroll down until you see N equals. And that's the one we want to turn on. Now, if you don't have the app, you can just, actually, you know what? Go ahead and punch things in with us. Just use the equals because you'll still get the two lines. You just won't get the shading. We're going to be able to see the shading and everything. So now, if I hit N equals, I have just turned it on. And I'm going to go into y equals, and now I get to choose whether or not it's equals or it's one of these other things. But for these, you have to hit the green alpha key first, and then hit the button that's right underneath this. So let's see what was our first one. You don't have any equals? Oh, okay. And the brand new ones, if you arrow all the way over to the left, it lets you choose. The brand new ones, if you arrow to the left all the way, it'll give you choices. So those of you that have the really, really new calculators, you're going to use this arrow, and you're going to go all the way over here to have this blinking, and if you press enter, it allows you to change it from equals to other things. Okay? Yeah, and right now there's like 3 different levels of calculators in the room, so everybody's is a little different. So what I have to do is I have to change that to less than or equal to. And that will be this one, which is under the zoom button. So I have to hit alpha and zoom. And that literally changes that to less than or equal to. And then I need my negative 1/2. Oops, forgot my negative. Negative 1/2 x plus 5. And then we have to do it again because the other one was greater than or equal to. So now I'm going to have to hit alpha and, get that on top of the equals, alpha and greater than or equal to, alpha and graph. And notice how this little thing says, I'm going to shade that one below because it's less than or equal to, and I'm going to shade that one above because it's greater than or equal to. And that'll be negative x plus 5. So now if we hit zoom 6, this is going to do exactly what we did by hand and show us that we had the right points. Zoom 6 does the shading and everything.
That is not shading. That's a bunch of stairs.
It does the shading like I have to do the shading up here.
Looks like my calculator is breaking. What's that on It's fine.
Oh, okay. Yeah, it does. It looks like little prison bars or something. You'll have your
Jail bar. Yeah.
Oh,
My calculator's breaking out.
Word it.
Yeah.
Here.
The state prison.
You do that.
Yeah, that one. That's how I do it.
Yeah.
Works at the one. That's the zero. Kidding. That one sucks. I went there and I almost threw.
The one by Panera?
Made my
He
stomach
probably
hurt.
made it too. How long ago was it?
Summer.
Was it before August?
Anybody else have any issues with it? All right. So what we would do here is we would realize, okay, we still are smarter than the graphing calculator. We know we're only using this portion. We're not going down into the negatives. We know that part. But this is good for us to check and see if things are going well. You know, are we getting exactly what we're supposed to get? Is it not showing up? So.
So I got a good job.
Where do you work? Oh, DQ, that's right.
I love it.
All right. So here's what you're going to notice. This takes longer than just doing it by hand. You know, getting it all in there like that. So it's great to check. If you have time to check, that's fantastic. But it does take a long time to get it in there and get it ready. And what we have to do is look at one that not only has a line, but also an absolute value today. We're going to take a peek at an absolute value inequality. Again, we already did these. This is not new. So let's color code. Oh, yeah. All right, everybody, what does y is less than or equal to 3? What does y equals 3 look like? Well, where does it equal 3? It is a horizontal line at 3. And it does have an equals bar. So 1, 2, 3. Now, if our inequality says y is less than or equal to 3, which way should we shade? Yeah, down. Yeah, that's where it's less than 3. 2, 1, 0. So there's our first one. It's a line. But the second one is not a line. And I know that because it has the absolute value bars. So I start thinking back. And I remember, if I can find the vertex, that graphing this absolute value is going to go really fast. So what's the vertex for our absolute value? 1, 0. Good, good. H and no K means it's at 1, 0. Now, do you remember how to get the rest of it? What if I say slope? 1/1, exactly. There's a little hidden 1 right here. So for the right side of the graph, the slope is 1. We already found our vertex at 1, 0. So from here we go up 1 and over 1, and then we go ahead and use a reverse slope for the other side, so up 1 and left 1. And then dash your solid. Oh, they got us, didn't they? Solid. You know, at some point we'd think we're going to have a dash, but we don't. These are all solids. And that's because of where we're going to go in the next section. There we go. All right. This one is solved for y. It says y is greater than or equal to x minus 1. So where should we shade? Up. Now if we shade up, that's going to be this stuff in here. So what is the shape of our double shading? It's a little triangle.
Yeah.
So those are going to work not only for the top inequality, but also for the bottom inequality. And that's what this was about. Both of those work. Okay, we got one more to do, and then here's the thing. I told myself that if we have time today, I'm also going to show you how to graph the absolute value inequality on the graphing calculator. So let's get the next one out of the way.
I'm gonna get out of here.
All right, let's color code. Top one. Looks like so. How does that one start? Up one. On the Y. Negative 1/3. Down 1 and right 3. It's finally a dash. Woo! Finally.
That is so gross.
This was solved for Y. Up or down for the shading? Up, down, up, down. Y is less than, less than. Switch colors. Where's our new vertex, HK? 1, 0 again. Yep. 1 and 0. All right, that's enough Scooby-Doo. Slope of the right side of the graph. 2. So up 2 and over 1. Backward slope for the other side. Up 2 and back 1. Dash this off. This one's dashed also. Twiggly shape. Inside the D or outside?
Outside.
Outside? Inside?
Outside.
Outside is down. Inside is up. Greater than. And this gets you a little worried. Do you see where it's double shaded? It's really hard to see it.
Yes, I see it. I see it.
Same.
Itsy bitsy little triangular thing down there. It's very, very small. That's the spot that they're both at. So, let's say I was really worried about this one and I wanted to check this on my graphing calculator. Turns out your graphing calculator not only does those inequalities, it also does the shading and it does the V and it does everything. So grab the graphing calculator. All right, you ready? We need Y is less than. So go back to this, arrow over the top of that, and then hit alpha, and whichever of these keys is below the one you want. So we wanted less than. So alpha, window, and that's going to change it to less than. And then we had negative 1/3 x, so parentheses. Please be quiet so everybody that wants to know how to use their graphing calculator for this can do that, please. Negative 1/3 x plus 1. That one's done. And then this one needed to be y is greater than, so that would be alpha trace. And then we need absolute value, 2 times absolute value. So put the 2 in. And I'm going to show you where absolute value is on your calculator. Is everybody ready? Well, you shouldn't have been doing your Scooby imitation before. You should have been paying attention.
If I was seeing people running. I didn't even know what that meant. Okay, we're ready.
Math, numbers, number 1,
The wrong button.
ABS. And on the newer ones, they even show up as nice absolute value lines.
Mine
And we want
didn't
to
show
put
that.
X
Mine
minus
are
1.
parentheses.
Can you do that again?
Math, arrow to the right once.
Mine are
Number 1.
parentheses.
Was this supposed to pop up next to that?
Yes,
Mine is parentheses.
and that's okay. You can still put it in the parentheses. It's just a little bit older model, that's all.
So I don't get the cool looking dashes?
We'll get everything. Yeah, we'll make graph. Now this is just a check, remember, we always graph this stuff by hand, but this way we can be sure it's just that itty bitty little thing that we saw, you know? And there it is. That's the only spot that's double shaded here, that itty bitty little triangular thing. That's it. Right?
Wow.
Again, if you don't get the graphing calculator thing, don't worry about it. We're going to do it by hand, but it's really nice to be able to check and see if your answers are right. And everybody's going to want graph paper, so let me get the assignment up and then I'll get you a piece of graph